Hi, my name is Bismark Amankwaa-Kyeremeh, and today I will be talking about sensing and optimization of flotation circuits and their integration with grinding. This is where my project sits among other projects in the consortium, and the main objective of this project is to have an improved, stabilized, and cost-effective flotation process. Flotation has been the main separation technique that has ensured the sustenance of metals like copper on the resource market. In flotation, we are basically separating minerals based on their difference in surface wettability. No matter how simple this may sound, the process is known to be a complex one affected by several variables, ranging from chemistry components to equipment components. Recovery and grade are the main key performance indicators, and the goal has always been to achieve the highest recovery at or above targeted grade. However, owing to the complexity of the process and the numerous variables affecting the process, precious minerals are lost to tailings, which leads to the loss of revenue. Imagine how cool it would be if we had a flotation system that automatically adjusts itself to achieve the expected recovery and grade when there is a change in any of the process variables. Well, for over 10 years now, several research work have been done to predict and optimize the process, as this will form the basis for the full optimization of the process. We intend to solve this industrial challenge with the use of machine learning algorithms. Machine learning algorithms can capture complex nonlinear relationships among flotation variables, take on more input variables, and they have higher prediction accuracy as compared to conventional modeling techniques. Machine learning algorithms, specifically supervised learners, operate by establishing a correlation structure between input and output variables, and with the use of this correlation structure, make a future prediction. Now, using data from the rougher circuit of BHP Olympic Dam, these are our main key findings so far. We have developed a predictive model from relevant rougher flotation variables, and we are able to predict rougher copper recovery and rougher copper concentrate grade using Gaussian process regression algorithm. Secondly, we extracted the predictive functions of these predictive models, and they were used as the objective functions for the optimization of both rougher copper recovery and rougher copper concentrate grade using Pareto search algorithm, where the non-dominant front was determined. Now the question is how useful these findings could be to the industry. Well, first of all, our developed models could be used to simulate rougher copper recovery and rougher copper concentrate grade, respectively. This, when done, would give mineral processing engineers at BHP Olympic Dam an idea of the expected outputs of the process. The figures shown below are true and predicted rougher copper grade and recovery. The main cause in the fluctuation of the performance of flow flotation is directly linked to the operation of the numerous process variables at different set points. This implies that once the various rougher flotation variables are operated at their optimal operating values as determined from this project, we expect a more stabilized and improved flotation operation on the mine. Finally, the developed models could be integrated into model-based predictive controllers. Model-based predictive controllers have the ability to anticipate future events and take the necessary intervention. However, the most difficult part in model-based predictive controllers is the development of predictive models, which this work has already addressed. These are the list of publications since the commencement of the project, which are 1 journal paper and 2 international conferences. At this point, I would like to acknowledge my supervisors, end-user partners, translation partners, PhD students and postdocs in the PRIF, as well as State Government of South Australia through the PRIF RCP Mining Consortium. Thank you for your attention.